Assalamualaikum and salam sejahtera. We are from group 2. We are given a task to solve a problem using mathematics tree application. We are decided to use chain rule in first chapter, multivariable function, as our main method for this assignment to solve a problem. We use Temenggong Dam as our group reserve place. As we know, Temenggong Dam is the third largest hydropower dam in Malaysia.
The problem is when we need to relate this application for engineering users. For the problem statement part, we need to know that how hydropower works, the contribution hydropower to residential, and the relation between hydropower in engineering and its users.
Hydropower is the process of using the energy of moving water to create electricity. The electric amount can serve 5.936 million people. What happens if the population of the area increased by 1 million? If the population served increase, the power support to be generated will be increased, and there will some change on the flow rate. The radius of the tunnel should be increased in order to overcome the population and power support. So, we will investigate and study the case to determine what if the population of the area increased by 1 million.
Hi, Dr. Arif. My name is Ipom Chen. I am from Section 1 and Group 2. Then today I will present about the calculation of the project. So, from the first part, the power is equal to the height of the dam times the river flow times the efficiency of turbine and generator, and divided by 11.8, where the power is equal to the electric power in kilowatts. 1 kilowatts equal to 1000 watts. Height of the dam is equal to the distance of the waterfall measured in feet. The river flow is equal to the amount of water flowing in a river measured in the cubic feet per second. The efficiency is equal to how well the turbine and the generator convert the power of falling water into electric power. Normally, the value will be 0.8. Then, for our project, we are investigate for the Temenggong Dam. The height of the dam is 420 feet. The radius of the power tunnel is 5.5 meter. The river flow is equal to 99.940 times 10 of power 3 cubic feet per second. The velocity of the water flow is equal to 119.12 meter per second. The efficiency is equal to 0.8. So our power is equal to 420 times 99.940 times 0.8 divided by 11.8 is equal to 2.85 times power 10 power of 6 kilowatts. For the electric energy, which is calculated in kilowatts hour, electric energy is equal to power times 24 hours per day times 365 days per year. So that our electric energy is equal to 2.85 times 10 of power 6 times 24 times 365 is equal to 2.4966 times 10 of power 10 kilowatts hours. So the average annual residential energy used in Malaysia is about 4,206 kilowatts per hour for each person. So we can figure out how many people our dam could serve by dividing the annual energy production by 4,206. So the people served is equal to the electric energy divided by the average annual residential energy use. So the people served is equal to 2.4966 times 10 power 10 divided by 4,206 is equal to 5.936 million people. So the other part will continue by my teammates Yap Si Kyung.
Hi doctor, my name is Yap Si Kyung. So I will continue the part B of our calculation. Okay, now before that we calculate the amount of people that we can serve by the dam is 5.936 million people. So we are asking with a question, what if the population of the area increased by 1 million? So when increased by 1 million, sure, the power will be increased. So there are some motivation have to do with the dam. So in this case, the population increased by 1 million, so the people served will become 6.936 million people. Okay, then we have to reverse the calculation to calculate the electric energy. So the electric energy will be 2.936 million people times 4206. So will become 2.917 times 10 to the power of 10 kilowatt hour. Now, when we get the electric energy, we can calculate the power. The power will be reverse the calculation. So it's 2.917 times 10 to the power of 10 divided by 24 and divide by 365. So the power is 3.33 times 10 to the power of 6 kilowatts. So for the river flow, we use the formula to rearrange the formula and calculate the river flow. So we can get the river flow is 116.946 times 10 to the power of 3 cubic feet per second. So we calculate in meter cube. So in meter cube per second is 3,311.54. So we're using this formula. So we calculate for the V. V is pi r square h for the cylinder. So from that we differentiate dVdh and dVdr, which is differentiate V in respect to h and respect to r. So r is our radius, h is our length of pipe. So dVdh is pi r square and dVdr is 2 pi rh. Then we will use the rate of change formula. dVdt equals to dVdr times drdt plus dVdh times dHdt. drdt will be 0 because there are no changes in radius when the water flowing in the tunnel. So the dHdt is a speed velocity of the river flow. So it's 119.12 meter per second. So for the dVdt, since drdt is equal to 0, we put that into 0. So it's 2 pi r times 0 plus pi r square times 119.12. So we substitute all the formula, then we can get the radius is 2.97 meter. So we calculate into diameter with times 2 becomes 5.95 meter for diameter. So in conclusion, in this calculation, if our population is increased, the diameter of the pipe will be increased, which is the diameter from 5.50 meter increased to 5.95 meter to overcome the increase of resident population and power support need to serve. So that's all for the presentation in our calculation. Thank you.
We can determine the solution to reduce the problem about the amount of power that we need due to the increasing of people population. From that, engineer can use rate of change method to design a solution by increasing the radius of the tunnel from 5.5 meter to 5.9 meter. So that's all from us. Thank you.